Light. Light electromagnetic radiation that can be detected by the human eyes. Electromagnetic radiation occurs over an extremely wide range of wavelengths, from gamma rays with wavelength less than about 10 to the power of minus 11 meter to radio waves measured in meters. Within that broad spectrum, the wavelengths visible to humans occupy a very narrow band, from about 700 nanometers, billionths of a meter, for red light down to about 400 nanometers for violet light. The spectral regions adjacent to the visible band are often referred to as light also. Infrared at the one end and ultraviolet at the other. The speed of light in a vacuum is a fundamental physical constant, the currently accepted value of which is exactly 299,792,458 meters per second, or about 186,282 miles per second. No single answer to the question "what is light?" satisfies the many contexts in which light is experienced, explored, and exploited. The physicist is interested in the physical properties of light. The artist in an aesthetic appreciation of the visual world. Through the sense of sight, light is a primary tool for perceiving the world around and communicating within it. Light from the sun warms the earth, drives the global weather patterns, and initiates the life-sustaining process of photosynthesis. On the grand scale, light interaction with matter have helped shape the structure of the universe. Indeed, light provides a window on the universe from cosmological to atomic scales. Almost all of information about the rest of the universe reaches Earth in the form of electromagnetic radiation. By interpreting that radiation, astronomers can glimpse the earliest epoch of the universe, measured the general expansion of the universe, and determine the chemical composition of stars and the interstellar medium. Just as invention of the telescope dramatically brought an exploration of the universe, so too the invention of the microscope opened the intricate world of the cell. The analysis of the frequencies of light emitted and absorbed by atoms was a principal impetus for the development of quantum mechanics. Atomic and molecular spectroscopies continue to be primary tools for probing the structure of matter, providing ultra-sensitive tests of atomic and molecular matter, and contributing to study of fundamental proto-chemical reactions. Light transmits spatial and temporal information. This property forms the basis of the field of optics and optical communication and myriad of related technologies, both mature and emerging. Technological appreciations based on the manipulations of light include lasers, holography, and fiber optics telecommunication systems. In most everyday circumstances, the property of light can be derived from the theory of classical electromagnetic systems, in which light is described as coupled electrics and magnetic fields, propagating through space as a traveling wave. However, in wave theory developed in the mid-19th century, it's not sufficient to explain the properties of light at very low intensities. At that level, a quantum theory is needed to explain the characteristic of light and to explain the interaction of light with atoms and molecules. In its simplest form, quantum theory describes light as consisting of This creates a package of energy called photons. However, neither a classical wave model nor a classical particle model correctly describe light. Light has a dual nature that is revealed only in quantum mechanics. This surprise very particular duality is shared by all the primary constituents of nature. For example, electrons have both practical light and wave-like aspects. Since the mid 20th century, a more comprehensive theory of light known as quantum electrodynamics (QED) has been regarded by physicists as complete. QED combined the idea of classical electromagnetism, quantum mechanics, and the special theory of relativity. In this article focused on the physical characteristic of light and the theoretical model that describe the nature of light. Its major themes includes introduction to the fundamental of geometrical optics, classical electromagnetic waves, and the interference effects associated with those waves, and the foundation of idea of the quantum theory of light. More idea and technical presentation of these topics can be found in article Optics, Electromagnetic Radiation, Quantum Mechanics, and Quantum Electrodynamics.